In this video, we're going to go over calculating a bunch of things on the force plate. So we're going to go over doing impulse, ground reaction force, impulse. We're going to get velocity, power, kinetic energy, and also jump height. We're going to do that two ways. We're going to first do it by using the force, and then we're also going to use the time off the plate. Let's first go ahead and just plot our data. So we got time here, and we got force. I got a reference up here on the right, mainly just because this is going to be a fair amount of things to calculate, and I may not remember everything right off the top of my head. It's just so I don't have to look up things as I'm doing this. So let's go ahead and plot this. Just take a look. I recommend you do it with your data as well, just to look and see what it's at. So what's going on here first is person is just standing on the force plate. Then we tell them to go ahead and jump, and this is their force, their ground reaction force. Right about here, their arms are starting to move. We can blow this up here. Their arms are starting to move, and when your arms start to move, you're going to put a little bit more force in the force plate. Then they're moving down here, so there's less force. Then at this point, they're starting to push back into the force plate, and it looks like they have a little bit of disconnect maybe between their arms and their feet for this one. That's okay. But then they're starting to jump, and this is their highest force right here. When the force plate reads 0, which is right here, they have left the force plate. So that we're going to use those couple marks. Here they return to the force plate and they're come crashing, so to speak, down. So I'm going to make a couple cuts first. Gotta go find out where it's 0. Okay, right here. I was just using my page up and page down. I'm going to put 2 cuts in there. Let's find out where. Okay, perfect. There. This is when they left the force plate. So these 2 points right here is the time and the force that they were off the force plate. So this is when they the last moment before they touched the force plate, and this one was the time that they left the force plate. Cool. Now I'm going to go back down here. We're going to determine where the jump was. So when they started the jump. Most people would say when they started moving their arms here. However, I'm going to move it just slightly over to when it crosses their body weight. So I don't know what their body weight is, but I am going to figure that out here. So let's just punch in body weight up here. It's going to be in newtons. So the body weight is actually going to just be the average for this person. Since they were standing on the force plate for a couple seconds, I can use just a second. A second will work for me. It'll depend on what your data looks like. Just use at least a quarter of a second, or 250 milliseconds here will work. So I'm just going to shift, highlight on down. I'm just going to go for a full second, just because more data points the better. So 1 second right there. Hit return. And this person's body weight in newtons is about 607 newtons. So what we need to do first is figure out the difference between the force that's being read by the force plate and their body weight. I'm just going to come back to here. I'm going to put some dollar signs in here. That's going to always point to the body weight for this. Then I'm just going to go ahead and hit the down. Or not down, but the edge of the box there. I'm using control down, and it might be command down if I remember right on Macs. Perfect. So that just did it for everything. I don't have to do it for all these almost 3,000 data points, or rows as it would be. We're going to do the jump. So what I'm going to do with this is I'm going to follow this up. Alright, so here it's negative. That's good. Low negative numbers here. That's when they are crouched down in the jump. So let's go ahead and see where this crosses. Oh, right here. Right here we're crossing body weight. So I'm going to add 2 cuts in here. Alright, now we can do the impulse. So it starts at 0 here. Now, this one plus the row above, this one plus that one, divide it in half. Then we're going to multiply that by the difference in time. And it is only, it's going to be the same thing all the way down, but I just have it set as is. Then we'll just double click that. And this will give us the total impulse. Okay. Impulse. This is net impulse, but it'll work, and that'll just be the sum of this. So 142, and that's going to be, units aren't nice, they work, but they're called Newton seconds. Alright, so one thing I'm going to do from here is we're going to get power, or sorry, velocity first and then power. Alright, so to get velocity, what we're going to do is we're going to take their impulse, divide it by their velocity at that time period, and velocity and divide it by impulse and divide it by their body weight. My apologies, and then multiply it by 9.81 or gravity, and then add whatever the number was above. We're going to do the cumulative velocity, as it were. So it starts at 0. All right. So what we got is got our impulse divided by body weight, multiply by 9.81, and then add that 0. Okay, it's going to be a pretty small number. One thing before we can hit the double, though, is we have to always point back to body weight. So make sure that's in there. Then we double click on down, and this is the cumulative velocity. And you can see it's actually going, as the person's starting to leave, or almost about to leave the force plate, it's actually going down. So, interesting. So, the velocity, this is in meters per second, is actually just going to be the max from this one. That's okay, the formula will fix itself. So 2.41, 2.42-ish meters per second. Cool. Now let's go ahead and do power. So power is just velocity times their force at that period. So again, it's going to start at 0 because we're multiplying 0 by whatever the number is. So equals to velocity times force, Fz. Yep, okay. Double click that on down, and we can see, some rather large numbers. And again, these are going to be in watts. Cumulative, well, this is, sorry, the instant power. All right, now we're going to go ahead and get a couple more things. We'll forego the power stuff just for the moment. We're going to do kinetic energy now. So that's going to be our body weight. So equals to, equals to 0.5 times our body weight. Our body weight in newtons. In kilograms, we've got to divide it by 9.81. Then we'll multiply that by their velocity squared. Whoops, that got out of order. Alright, so 180, great. And now we're going to do the jump height. And that's just going to be our kinetic energy divided by our body weight in newtons here. We're doing things a little bit more unnatural than some of our usual equations, so that's why I got this reference. It's for you, it's for me. So let's go ahead and kinetic energy. All right, now we'll go ahead and do that, which is kinetic energy divided by body weight. This gets us meters that the person jumped. I'm going to go ahead and multiply that, divide it by 100 to get, that'll get us into centimeters, and then multiply by 2 point, yeah, let's just go ahead and do this all out. So this is our height in meters, then we'll take this and divide it by 100, multiply by 100. And that's height in centimeters. And lastly, we'll convert this to inches. So that's going to be divided by 2.54. Height in inches. Cool. Great. And then lastly, let's just figure out the potential energy when they're at the height of their jump. And if I remember right, one thing I'm gonna add in here is actually, never mind. We won't go ahead and do that. We'll just do the power calculations. So peak power. This is going to be in watts. This is going to be the max for this. And then watts per kilogram. This is going to be this divided by their weight in kilograms. We gotta type that in correctly. Need that parenthesis. Divide by 9.81. And then we'll do the average. And this average is only going to be for their the positive numbers. It's not going to include any of the negative power numbers that we got. So let's go ahead and do average power. Oh, whoops, I didn't mean that equal sign. Again, watts. This is only when it's positive. It's going to be quite a bit of numbers, but it will go eventually. There we go. Changed real quick there. And then again, watts per kilogram. All right, so we're almost finished. Now we're going to go down to when they're off the force plate. All right. Okay, sorry, I lost track of where I was. There we go. All right, so we need a half amount of the time, because half the way up, half the way down is at least what we're assuming here. So their total time off the force plate, divide it in half. Then what we're going to do is we're going to figure out what their velocity was, approximate what their takeoff velocity and landing velocity are. So to do that, we're going to take that height and multiply it by 9.81. It tells us velocity, assuming one of those velocities, either the final or initial, was 0. So equals to this times 9.81. Then we're going to figure out jump height. We're going to do that using 1/2 gravity times their times their height squared. So 0.5 times gravity, and then multiply that by time squared. So that's again meters, and that's based off of this. Now let's do the error. That's going to be a percent parenthesis minus, we're going to figure out how much air there is between the impulse method that we used and this time-based method. And we need velocity times 100 divided by this. We're going to use that as the comparison velocity here. So we had about 3.51% air based off the velocity. Between the methods. And that's not too bad. This is a heck of a lot easier, you can see here. We don't have to do as many calculations, but again, this has some air to it, more air to it than the other methods. So that's why we have these different methods for it. Otherwise, this is, you'll have a you have your own to do this on if you are just watching the end of this video. Please let me know if there are any questions. You'll just have to take these numbers and transfer them into the Excel sheet or into your worksheet. But if there are any questions, please just let me know and I will answer them as best as I can.